So much, David, for the lovely introduction. Cool streaming things, cool video things. Maybe, we'll see. Good evening. Thank you so much for having me in Seattle. Not my first time in Seattle. Been here a few times before. Been in this building before, actually. I'm going to talk a bit about the future of SSAI on OTT devices. So a little bit about me first. Everyone has to do one of these slides. I'm a streaming specialist, which I think is a unique job title in the world. I'm not sure anyone else exists for that. I've been in the video industry about 10 years, spent kind of 5 years at Bright Cove, 5 years at the BBC working on BBC iPlayer. I'm pretty active in the video dev community, be that on Slack, be that on the DMUX podcast, or be that on things like the London Video Technology Meetup. So I've been doing this quite a while. I haven't got a summary slide in here because I copied this slide off a lightning talk version of the same version of a talk. But a little bit of history. I'm going to start with a bit of history. We're going to talk about video adverts in browsers. So about 5 years ago, we're all talking about kind of client-side advertising, pretty simple kind of architecture, the browser talking to the ad server directly, getting creatives, playing them at the appropriate times. Then we'd fire beacons off from the browser to report impressions, kind of a pretty simple sort of experience. Now, this was inherently limited by the browser technology of the time, right? We couldn't kind of run multiple video elements at once. We had to often tear down and rebuild the entire video stack. Pretty poor user experience. You'd often get buffering between content in the ads, black frames. The transition would suck. Sometimes we had to kind of put a player on screen, hide it away off screen, put it back on to improve the performance. This is pretty sucky. So the good news was browsers started getting better, so we got kind of more concurrent HTTP requests. Bandwidth at the same time was improving, which helps a lot. And browsers are starting to really get this idea of multiple video elements, and then, hey, the quality of experience for the user improves, and kind of everyone's happy. Well, the user isn't because they're seeing more ads. So then we got ad blockers. So these appeared as browser plugins, right? So uBlock Origin, AdBlock Plus, these sorts of things are still around today. They start blocking the HTTP requests to the ad servers and for beacon endpoints at times, which is a whole different problem I'll talk about later. This tends to stop the ad playing, mainly because we've gone and built really resilient players, right? We've built web players that are like, hey, I couldn't get to my ad server. Oh, well, that means the ad server's probably gone down, because that sometimes happens when large concurrent events happen. So we just kind of stall for a second or 2 seconds and then just continue playing content, right? We build resilient players. So this pretty much sucks. The ad industry was pretty shocked at this state of affairs, so SSAI was invented. SSAI was kind of sold as this solution for ad blockers initially, right? Kind of some of the early products were kind of Unicorn Media, YoSpace, still around obviously, both been through now acquisitions, kind of more recent platforms like Google DAI, Uplink, MediaTailor, those sorts of platforms. But I said I was going to talk about OTT devices, right, rather than browsers, and OTT devices are really different to browsers. Viewers inherently, ridiculously, have a completely different expectation when you're on a television. As soon as you plug something into a television, they expect a television-like experience. It doesn't matter to them that it's a Linux box underneath a TV. It's totally different expectation. So they want fast startup times, no buffering, no black frames, audio normalization, really important. But there's very few ad blockers on TVs, so kind of the reasoning becomes really different. So there are a few ways you can block ads on your smart TVs and your Apple TVs. Pi-hole is one of them, but the deployment of those sorts of technologies are pretty low, though. But on the flip side, these devices have very little RAM, useless browser engines, so we're kind of in the space where your smart TV is a 5 to 8 year old web browser. So client-side advertising advertisement kind of sucks again. So we talked about SSAI. How does it work? So there's a couple of approaches. First one is what I'll call manifest manipulation. This is the common predominant technology of the day. When a manifest request comes in, you go hit an ad server on the server side, you check if you've got some ads cached. If so, stick them in the stream, use some magical markers, but if not, transcode them, hope they come up again. If you're using Google's solution, they actually share the ad transcode and do upfront ad transcode and clever stuff like that. Pretty simple architecturally, no special stuff going on. You have a manifest generator, you have to scale that pretty high because you want a different manifest per user, and pretty much just a traditional media store and CDN arrangement. This is what it looks like in the manifest. Should be pretty common to most people. In HLS, we use the discontinuity tag. Just signals, hey, you need to think now to reset your decoder. In Dash, looks a bit different. We have something called multi-period Dash, period of content, period of add, period of content, those sorts of things. Pretty simple, all signaled in the manifests. There's a second approach that is less common, but interesting in its own way, is timestamp rewriting. So still generates a manifest, unique to every user, but also rewrites all the time codes as you request segments. This means that there isn't a discontinuity between content and ads. You usually have to use a redirect to get between the content and the ad, but most devices follow those. This is pretty great for OTT devices. This is pretty terrible for caching strategies, and I'll talk a bit more about that later. It's pretty much the same architecture. You just have to have this magic timestamp rewriter thing, which is totally an easy problem to solve. There are no edge cases there whatsoever, and particularly none in audio. So manifest manipulation sounds great. It's really easy to understand, so we should probably just use that everywhere, right? That's cool. So let's look at the devices we're talking about, right? I think there's about 4 classes of devices in the living room. This is what I call them. Netflix actually called them something subtly different. This is my terminology. Streaming boxes, smart TVs, set-top boxes, and games consoles is what I group them together in. So I'm going to show you some support grids, some device support grids for certain approaches to doing ad insertion. I actually built this talk for a European conference a couple of months ago. They're not hugely tweaked to the American market, but they're pretty accurate. We're trying to use the native player wherever possible, or using MSE, MEM polyfills. And we're also talking about devices that are modern, so 2018, 2019 devices running up-to-date firmware. And I originally had this as kind of your mileage may vary. The honest truth here is your mileage will vary, depending on what you're willing to invest and spend on developing for these platforms. So let's talk about kind of the good first. The streaming boxes, so the Chromecasts, the Apple TVs, the Rokus, the Fire TVs, these sorts of things. You can target these devices pretty well with things like HLS with discontinuities. Actually works natively on all of these. Only gets you so far without DRM. The only place you can HLS with DRM is obviously Apple TV. When you're talking about the other devices, multi-period Dash kind of works pretty much just fine across these devices. So this is the good situation. Then you get to bad devices, kind of the so-called smart TVs. This is a bit of a mess, really. Some of them will play it natively, so HLS with discontinuities tends to work pretty well, but again, that doesn't get you anywhere if you need DRM. Kind of native multi-period Dash with DRM is pretty much just a non-starter. So you're into the realms of kind of, okay, well, I need EME and MSE, and even then it starts to fall apart when you kind of try and switch quickly between a lot of different periods and a lot of different ads. These devices might be able to support maybe 2 concurrent video decoders if you're lucky. It's also interesting to note that on some of these devices you kind of have several options. You can either target the native player, or you could target the MSE player, or in some cases, some of them also run Roku TV as an app, and you can kind of target into there, and you can get different success there. This varies wildly by region as well, what software these devices are running. The Samsung OS out here is totally different to the Samsung OS in Europe in terms of release and performance and behavior.
Are you saying that support for multi-period Dash with DRM in smart TVs requires 2 players?
I am saying in some cases, the implementation of MSE will entirely spin up and down a video stack. So if you can't swap in another one, you're not going to get far. There's the ugly devices as well. The set-top box, I didn't even try to draw up a device grid for these because kind of every device is different here. There is some good stuff coming up in a little bit about this, but you know, in Europe you might have a HBB TV decoder on all these devices, which helps. But there's really very little support out there in the set-top boxes. The value of going after these devices is really minimal. Remember what I call the forgotten devices, these games consoles. A lot of people forget that these are totally media devices these days. Xbox One does really well here. You can get away with HLS with discontinuities, you can get away with multi-period Dash. All these things work quite nicely. PS4, Sony have repeatedly told me this works. I'm really yet to see an example of this working without huge amounts of development on a development team. So I say it doesn't really work. If you're not willing to do kind of fully custom player development, I kind of disagree that this works.
HLS with discontinuities should work on Xbox One. Oh, HLS with discontinuities should work with Play Ready.
Oh, and yeah, the Play Ready version as well. I've forgotten about that one, actually. Then there's a Nintendo Switch, which still not answering my questions.
You say over here, Play Ready, Widevine, the DRM. You're talking about the full stream to be encrypted with the Play Ready or Widevine?
Yeah. So
The main content.
this is a great question. Am I talking about the whole stream being encrypted and also potentially with the same keys? Is that also something you're implying? Okay, so I didn't go into this in detail. Most of this assumes that the ad is either completely unencrypted but correctly signaled as unencrypted, or that the ad is encrypted consistently with the same key, which is much more around the kind of timestamp rewriting, because you need to JIT encrypt your ads with the same keys as well. Most of this is around, there totally are smart TV devices that fall over when trying to turn off the encryption and then turn it back on again. I've seen that. Great question. It is a problem. It is a mess. My support grids are very much around swapping to a no encryption on the ads and then back again, rather than a different encryption key. Yeah. So if you kind of look at that as numbers, streaming boxes, we got good coverage. This is great. One devices. Smart TVs, maybe 90% best case if you're willing to put a lot of investment into it. Set-top boxes, I don't know, complete wash really. And games consoles, maybe half of them if you're lucky, depending on what deployment numbers you think people have in their households. So we've got some problems. Smart TVs, definitely one of the problems. But there's a bit of a problem beyond this. We don't have a complete picture on smart TVs because, like I said, I was talking about 2018, 2019, up-to-date firmware on devices. Here's some numbers from the UK. So the UK has maybe, this is the best stat I could come up with, a 42% coverage of smart TVs in the living room. The uptake of streaming boxes is actually pretty low in Europe in general, but we have very little data on the age of these smart TVs in people's living room. The best I could do was look at the historic data about how people were buying smart TVs. And that's what this looks like. So roughly speaking, smart TV adoption in the UK specifically, your mileage will vary, was about 6 to 7% a year and is actually starting to slow down. But if you take that data and regress it, it comes up as 28% of people bought a TV 3 years ago, a smart TV 3 years ago, and 14% have bought within the last 3 years. So this is a big problem because old smart TVs suck. So your capabilities trail off massively when you're talking about older smart TVs. You can have out-of-date firmware. They can actually totally not have access to the App Store anymore. Sometimes they do have access to the App Store still. Sometimes you can't actually release anything onto the App Store for these devices. This is hard to detect. Sniffing device versions is an art in itself. But basically 3 years ago when I kind of started working on manifest manipulation, there was really no support out there on these smart TVs. I think this kind of goes nicely into a graph. This is very rough kind of estimation stuff, but if you look at it, within the last 2 years, you're talking about, you can target modern smart TVs, you might have some success there. When you kind of get down to the 4 years old, you're looking at these streaming boxes and games consoles. When you have this long tail, you can still buy a pretty outdated Apple TV that actually does support discontinuities because you actually still get a firmware update for that as opposed to things like smart TVs where the firmware support goes very quickly. You probably want some solutions to this. So the first thing I do before you kind of want to actually solve this problem is figure out what the scope of your problem is, right? So what do your users have in their living rooms? So I have 5 devices that support Netflix as an example. I'll talk a little bit more about Netflix in a second, but that's my smart TV, my Xbox, my Switch, my everything supports Netflix, right? So you need to figure out what the devices are that will actually get you the best coverage. It might be that, for example, going to games consoles, very popular in people's living rooms, is way more valuable than certain smart TVs is. So survey your users, but most importantly, remember, in the nicest way, I don't think anyone from Netflix is in the room, are they? No, great. So,
People from Hulu.
Hulu, there you go. They're competitors. You are not Netflix, and you probably shouldn't try and be Netflix, not initially. What you can do to avoid these problems is things like falling back to no ad fill on certain devices. This is going to be really unpopular with your business teams. But honestly, the cost, for example, of going after like a 2014 LG TV that might have 0.2% coverage is never going to justify itself on the actual CPM you're going to see from those devices. It's just never going to be there. The devices, like their old smart TVs, they might not even support Dash, let alone DRM, let alone multi-period. These people also potentially have a limited income at their disposal. If you're on an old smart TV, maybe not the primary target market for people with a high CPM value. For some devices, though, as you mentioned, DRM is the limiting factor. Maybe it's switching in and out of DRM decoder. There are often licensing solutions to this problem. Sometimes your license might say that, hey, if you're in SD, you don't need to DRM the content. So you maybe want to actually potentially make a trade-off here. So say, hey, rather than doing ad fill on these devices, if I want to get ad fill, I'm going to have to drop, artificially limit the resolution so I can make that work. So in some cases, you might want to say, well, HD is more valuable than ads, or ads are more valuable than HD, those sorts of things. This is potentially an option. I believe this is kind of starting to disappear out of studio contracts. 3-4 years ago, this was very common. I suspect it's starting to disappear, though, now, unfortunately.
So hey, Phil, what happens, how does the landscape change then when we're talking about 4K content that theoretically
I would bet good money. So, sorry, repeating the question, does it get worse when we're talking about 4K with... I don't have the data on that. I would guarantee it gets worse with kind of a full hardware chain as well. For example, if you're saying, and I have to use Widevine L1, stuff like that, I would absolutely guarantee it gets pretty notably worse, if not disastrously worse, I would guess. Great question.
But if it's going to be a device that can support 4K, it's probably not one of these archaic.
This is true. It's probably going to be one of the most recent, but the flip side of that will be you're probably using up more of the resources on the device when you're decoding. So you probably have a hotter RAM, hotter CPU, which might mean you can't do many things concurrently on that device, which is totally something I'll mention in a minute, assuming I'm using my up-to-date slides, which I may not be. This is one of my favorite solutions to this problem. Start sending people Chromecasts. I've worked on several projects that did this. I'm aware of kind of 4 or 5 more, so I know people are doing this. So yes, old devices are eventually going to cycle out of people's homes, but there's relatively few drivers coming for people, particularly to upgrade their smart TVs. Samsung will tell you there's loads of reasons. You'll go buy an 8K TV. You can tell the difference in your living room, right? No, my TV's this big. Send people Chromecasts. It's an option. They're very cheap in comparison to, especially when you buy them in bulk, they're really cheap in comparison to going and building custom apps on smart TVs. This has happened in 2 projects I know of in Australia. In particular, certain TVs can no longer get onto the App Store out there, which was a complete blocker to ever upgrading an app to add ads in. Worst case, in my opinion, you can resort to server-side stitching. If you're really, really sure you need to be on every device, server-side stitching will solve a lot of problems because you don't need signal discontinuity, you don't need to tear down and rebuild any decoders. There's big penalties for this, mainly that your cache performance drops by 30 to 40%. This obviously comes with a cost associated with it because origin egress is expensive, often the most expensive piece of building a product. You'll need origin compute. You can't use a dumb origin anymore. You have to have a smart origin. Your edge compute requirements, you could approach this using edge compute. That will increase requirements dramatically. Probably won't be frame accurate because you're going to want to start bucketing users to make better cache performance, make up the cache performance you just lost, which takes you further from this broadcast-like experience, which is what inherently people are looking for on their TV. Now, I said I was going to talk a bit about the future of SSAI. So there are some upcoming standards that are hopefully going to help with this. So while we target this discontinuity-friendly hardware that we've got in the market right now, we're also going to hopefully work to standardized solutions. So I'm going to talk about Europe quickly first. The HBB TV advertising standard standardizes a set of things on the device, things like available resources around midstream switching, signaling for when you can transition, all these sorts of things. And this is trying to get to a broadcast-like experience. And this is John Piesing, very smart guy. One of the big things they're doing here is they're also including a lot of test vectors, which is...
Are those HBB TVs standards
Yes.
or DVB standards or both?
I think they are all HBB TV standards as far as I'm aware.
And some of the signaling you're talking about client signaling?
Yes.
About capabilities through HTML5?
Yes, and some of that's actually coming out of, slight like, some of that's coming out of -IF, slightly more than it's coming out of...
Those extensions are not being worked into the device capability extensions that are being discussed?
They are annoyingly not right now, not as far as I'm aware. Yeah.
That's the great thing about standards is everybody has their own.
We definitely need a new standard for this.
There is a standard.
Yeah.
HTML5, so
There is.
I think we have a chance to, we have at least have a place to party. But that, I've talked to John about this several times. He needs to
Yeah.
keep on the GitHub issues list for that group.
Yeah. Get back on WCAG, I think, is the appropriate place for that one. You're right. Sorry. I've got one with the microphone. So the question was around if this was coming out of just, oh, you actually have the microphone.
Go ahead.
No, the question was coming out of, is this just a HBB TV effort? Is this coming out of DVB as well, or -IF? And the answer is this is predominantly a HBB TV effort, as far as I'm aware. This is particularly one of the things they're focusing is ad replacement. So live linear ad replacement, where you're watching something that's coming in on DVB stream, but you want to replace those ads with targeted ads from a video stream, from a HBB TV IP stream. I'm not super keen on this, but it is part of what they're trying to do. And this is part of why the requirement includes, for example, to be able to run multiple decoders at the same time. So you can't really turn off, you're effectively rendering a HTML5 web browser that is inherently transparent, actually, on top of your traditional DVB stream, which means you kind of need two decoders at once to be able to make that work at all, really. But doesn't help the US market much. And this is when I go to a slide that I hurriedly wrote this morning that just says ATSC free. I was informed earlier this week, hopefully ATSC free will help with a lot of this. This was talking to John actually earlier this week, that a lot of kind of the HBTV-esque dash standardization within kind of broadcast standards is coming into ATSC free. I haven't had a chance to read up enough to be completely confident this will help, but I'm hoping this helps.
The principal, is this on? I guess I can't hear myself. Okay. The principal problem here is who's referencing the ATSC specifications?
It's on.
Oh, okay.
It's just a recording.
Oh, it's just right. It's who's referencing the ATSC specifications. It's not like everybody out there is going, oh, here's the way it's done in ATSC, you better start moving there.
Yep.
And if anything, ATSC is trying to stay kind of in lockstep with the WAVE project, where the WAVE project's trying to orchestrate how CMAF and HTML5 are used for, and where all the HLS and dash interop issues are trying to be sorted out.
Yep.
So, so I think this is but John Piesing is very active in the WAVE project as well.
Yep.
So this is a place where we maybe can get that sorted out.
Yeah, I'm hoping to get stuck into this because this is a win for everybody. So I'm hoping to get pretty stuck into this one next.
Is there any sense of whether like IEB Tech Lab is involved in or looking at it from a spec perspective, the HBB TV stuff?
Sorry, was that IAB Tech Lab?
IEB Tech Lab, so it's Interactive Advertising Bureau, basically
Yeah,
the
yeah.
ads tech guys, right? So it's sense of using them to leverage. I don't know if they're involved.
I don't know if we're involved in ATSC free. I'm not sure. You might know better than me actually, but I'm not sure if they're actually dug in. I'm not sure on that one actually. So I had a conversation with this earlier today. Beacons and SSAI. So this is a really interesting problem that's starting to become prevalent. So beacons are what make sure you get paid, right? So when you request something from an ad server, a payload, you stitch in some ads, you put some signaling in, and then when people actually watch content, we send beacons over to beacon receivers, which talk to the ad server, eventually often delayed, that say, hey, this person actually viewed the ad. Therefore, you get paid as a vendor or as anyone who wants something to do with ads. Lots of kind of the older SSAI solutions included server-side beaconing. This was very popular. This was good because it meant that beacons kept working when people had ad blockers. They're a little bit questionable because, hey, just because a segment's been downloaded, which is the best indication you've got sometimes, you may not be 100% sure that that segment was actually viewed. The player might have pre-buffered, 2 minutes of content, and then somebody may have closed the player before it got there. Server-side beaconing is becoming less accepted by the ad networks, in particular Google are pretty much saying no to this these days. So what you've ended up with is this hybrid SSAI, CSAI system where you're doing SSAI stitching, but you're still kind of giving a VMAT back, and then you're emitting all the beacons from a client. So problem solved, except a lot of those beacons are now being caught by ad blockers under the kind of umbrella of privacy. A lot of, I think it's EasyList, lists a load of these beacon endpoints, which means that you're kind of worst case situation because you've put the effort in, you've rendered an ad, you've shown it to the viewer's got grumpy because they've seen an ad, and nobody gets paid. So everybody kind of loses in that situation. So this is going to be an ongoing challenge. Talking about it earlier, actually. Interested in coming up with educated solutions here. The growth in programmatic is going to be a big challenge. So it's going to cause way bigger ad catalogs. It's going to cause ad requests to slow dramatically. I've seen, wrappers that go into, 4, 5, 6 bidding layers deep and kind of bubble all the way back up that can take, 10, 20 seconds to resolve to find an ad. It's going to slow down startup times if you do this kind of synchronously and upfront when you do an ad playback. And this is going to make ad stitching on the server side way less effective because your ad catalog is just going to become super unpredictable, which is kind of worst case for everyone, really. So, in summary, smart TVs and set-top boxes suck at manifest manipulation still. They're getting better, but they still fundamentally suck. So target living room devices, target up-to-date devices, target things like your smart boxes, your Rokus, your Apple TVs, those sorts of things, and go spend your money and your effort elsewhere. But you're not Netflix. Maybe trying to be Netflix, but be creative, be good at what you're good at. Maybe that's creating content, maybe that's QoE, mobile, things like that. But you don't have to spend all this money. It's often not worth the investment to invest in all these smart TVs, whereas you could go and do something else that's way more exciting, way more innovative, and not cost you too much in your audience size. So with that, I will happily take questions, corrections, comments, anything, email, now, later, anything like that. I do have to say thank you to Mux, who pay me to travel around and talk about things. If you are interested in an analytics product or a very powerful video API, please do reach out as well. We can help you with those. But yeah, if anyone has any questions, please don't hold thy tongues. Also applause, please.
So John, the microphone's actually not working.
Oh, it's not working.
Oh. I will repeat.
I feel so fun.
You should always speak into a microphone if you have the option.
I have a loud voice, so people. So on the ad blocking side, you were specifically talking about browser implementations.
Yep.
One of the things that there's a trend towards progressive web apps across the industry, and in my opinion, it's likely that people will block the creation of ad blockers in the creation of PWAs. So if PWAs get a lot of use, that's going to address some of the ad blocking issues.
Absolutely. I'm yet to see PWAs get a huge amount of traction on smart TVs, but who knows? Soon, maybe.
That is the problem.
Yeah.
But on streaming devices,
Yep.
which you're right. The big problem with smart TVs is the lack of consistent browser development. Their implementations of EME have barely met the letter of the specification, and many of them are based on Google's early 1.5B or whatever it was specification for a widevine CDN that goes back from before the publication of the spec.
There is, I was looking at this today because somebody posted in Video Dev Slack. Google now have a pretty good set of, it's actually under the YouTube organization, but it's a pretty good set of benchmarks, HTML5 browsers now, that exercise EME and MSE specifically, which is supposedly what they use now to certify devices. Someone from Google in the room, please tell me I'm wrong, but my understanding is that's what they're now using to certify smart TVs, set-top boxes, that sort of thing. I haven't run them yet on anything, but I'm going to have a play with them next time I have a cheap smart TV to hand. I can't remember the exact repo, but I can share it around. So
Someone at YouTube did that.
yeah.
That's good.
Yuri.
Is there overall morale of the stock as like this one? If you can't figure out how to get things done right, learn to enjoy doing something.
It's a fair statement. I don't disagree. The moral of the story in my mind here is it's not critical to be on every device. It's certainly not critical to be on every device with ads. You can do way more exciting, innovative stuff with your time and research money than spending it getting, I've sat in rooms on eBay in the middle of the night, TVs, to try and debug a problem that some customer down the road has said, hey, it doesn't work on my smart TV running this version of software. And I've sat there and I've driven out and bought smart TVs from people that are like, why are you bidding so much on this old smart TV? Because I need that exact smart TV. When I start emailing them questions about exactly what software is it on, I don't know. Way better things to spend time and money doing than chasing old smart TVs in the middle of the night. Well, maybe you guys don't, but I've got better things I'd prefer to be doing.
So I have a question. So otherwise, are you pro SSAI?
Ooh, yeah, I'm super pro. Am I pro SSAI? Was the question. I am super pro SSAI. I have worked on kind of fully stitched solutions. They're not great. I appreciate they're also going to get worse in the future. CSAI, I just don't think we're ever going to really see a place where kind of smart TVs get really, really good at CSAI, just because at the end of the day, everyone's penny pinching on exactly what, RAM and CPU, It's kind of crazy because I've bought TVs in the past that brand themselves as kind of 8-core, but then they have next to no RAM and next to no storage and, a single hardware video decoder. So I just don't see a place where we're going to get to a really great experience, a great end user experience, if we're just relying on full client-side ad insertion on smart TVs. My interesting point for me is, the smart streaming boxes, the Rokus, the Apple TVs prove that, this can totally be done well. A server-side solution can be done really well with discontinuities, and it can still provide a great experience to the user, or at least a broadcast-like experience, let's say. I'm not sure all users would call it great, but a broadcast-like experience can be achieved. And there's some really interesting stuff coming out of Google that's totally worth a look around doing really large events with server-side ad insertion. For example, preemptively doing your ad requests in the kind of 2 minutes before your actual ad break comes up to distribute the load so that you're not doing, 1 million concurrent ad requests, you're doing, 10,000 over the space of a few minutes concurrent, and that kind of enables much bigger, if you're coming up to a big ad break on a big event, and that enables much better experiences as well for users. I am pro SSAI, would be simple. Pro SSAI, but pro manifest manipulation, long term. Just got to figure out all these rubbish devices.
You made a comment about how few of these devices, especially smart TVs, are capable of having two video decode pipelines. And I've heard this anecdotally many times, but then when I try to find out the ground truth about it, I can't seem to determine how true it is, or at least I can't find a list of devices that do or don't support it, or how they indicate whether or not they can support it other than...
There is no list. What I actually wanted to do originally when I pitched this talk in Europe, I guess 8-9 months ago now, was I wanted to get that exact list for kind of every device and every model and those sorts of things. But the vendors lie to you about what the device is capable of doing, the nicest way to the vendors. Maybe they just don't understand what you're asking or exactly what you want to get to, but they don't give you accurate data. Even if you talk to kind of the people who are kind of best at this in the industry, they kind of say, you know, your mileage varies massively depending on firmware version, and actually getting that data. I have a really good guy in Europe who pretty much just does smart TV development, but will only build video apps, smart TVs. And he's got some pretty good data, but he's also got a room like this of smart TVs. From the last 5 years, mostly British ones, but also kind of some more generic European ones. And I've been working with him to try and get a good handle on exactly what the devices are capable of.
Fraunhofer Focus
Yep.
in Berlin has a lot of this.
Yep.
We were there.
Yep.
They have a lot. They do a lot of the HBB-TV certification
Yep.
testing. But that was my other question. Do you know what the HBB? What are the reasons why HBB-TV is the exception to this whole problem, or to some degree an exception, is because they actually have a specification, say, hey, here's what you have to implement, and
Yep.
they have tests and so forth. Do you know what they say about what a smart TV has to be capable of? Does it have to be able to support separate simultaneous video buffers?
HBB-TV 1.5 and 2, you do not have to have concurrent buffers playing at once. You absolutely don't. It's a full teardown, full rebuild. The advertising specification, I believe, adds a certain number. I can't remember what the exact number was that they settled on. I think it's obviously at least 2. I believe last time I looked at some of John's work, it mentioned that it had to, I'm sure it's free, because the concept was if you're doing kind of linear, you want to be able to at least kind of get one ahead. So that kind of makes free when you 1 + 1 + 1, going back to the feed from live. I can't remember what the exact number is, but the HBB-TV ad specification will include a minimum number.
When those, it's not like they're building HBB-TV televisions. They're building
Yeah.
televisions that support HBB-TV.
Yeah.
Those TVs, if they do implement the advertising profile of HBB-TV, are going to get better at supporting
Absolutely.
video pipelines
Yeah.
for their U.S. TVs as well. Right? Because aren't they not building a special SKU
Yeah, but
in hardware?
I would actually have some information on that from my time at Dolby. Most TV manufacturers build SKUs specific to the region. They'll actually have
Yeah.
different chipsets for both the
Yep.
SoC and even the tuner package
Yep.
based on like European model, US model, Japan, Korea. So yeah,
I-
unfortunately, benefits for a
Yeah,
European TV
it-
model are unlikely to be there for a US model.
Well, there's a sad trombone.
Yeah.
Yeah.
I actually have a TV at home that is a certain model number, MU 7000, whatever it is, from Samsung. Completely different television in America. Like a completely different set of specifications, like local dimming versus no local dimming, and it's not software lockout, it's like even complete hardware differences. So if all you did was look at the pure model number without the like knowing what region it's in, it could have a completely different set of capabilities.
So the question then becomes whether or not ATSC is trying to do the same
Yeah.
thing for, I mean, I don't need to,
For
because
the
everyone
American,
can finish the
yeah.
sentence. And then the question then would be that, would the TVs in the US start to have this capability?
Also, there is a little bit more frustration on top of this, which is that the capabilities kind of from a HBB TV standpoint may not actually match what the native browser can do. So you kind of think of it as just because HBB TV can do, like it has HBB TV, that means it can do 2 concurrent. It may not actually mean that if you replicated the same thing using MSE and EME in the browser, that it would do the same thing. Or if you launched a native app, it would do the same thing. Those are all kind of mysteries.
So the HBB TV spec is, it for the advertising is type 1 playback where you're passing
Yep,
it to
you are
the
passing an
manifest
XML down to the decoder and saying off you go.
and say, play this.
Yep.
Okay, I didn't-
Yeah, absolutely. It's a full hand down to the native
So for
player.
those who don't know, there's like these 2 different models for adaptive delivery playback, where one model is where you go to the video tag, you pass the manifest, be it HLS or dash, directly to the video tag, and then the TV knows how to parse it and do all the work. And the other is you use media source extensions,
Yep.
JavaScript does everything. And what Phil's saying is that just because it's handling it for
Yep.
you, if you try to do it all in JavaScript, you might
Yep.
run into a memory problem.
Yep.
or-
Your mileage, like, it may not be completely implemented in the browser engine. It may not be. Yeah, it is. It is totally totally potentially, like, for example, I know in Tizen, right? So Samsung's hardware, the European revisions for doing something using MSE and EME is pretty heavily different to just passing a dash manifest or a smooth manifest down to the native execution environment. I've done both routes. Both have their own quirks and limitations. The good news is in Europe, I don't know if ATSC is going to do the same thing, but in Europe you can basically hide a HBB TV app as a native app. So you can package it in a way it still appears on the App Store, it still looks and feels like a native app, which is great. It's exactly, kind of like a PWA for smart TVs. So that is actually beneficial, because if you can do that, then even better. So you stop having to care about the fact you can do EME, MSE in a browser. You can just go to, I want to do a HBB TV app, but I want it to also look like it's in the App Store, which is quite a nice experience. I'm being told time by David, so.
But Phil will stick around.
I will stick around, I will drink more beer, eat more pizza, and yeah, pretty much my raison d'etre, actually. Thank you.
All right, up next is Brian.
Talking about HDR formats and trends in HDR. I'm going to keep this very interactive because we could go very, very deep technically. So I'm not entirely sure where the audience is at. So please stop me and ask any questions at any point, and I'll start tailoring it to the general knowledge of the audience. So a little background on me. I've been at Prime Video a little bit over 7 months as the principal product manager for video encoding and media technologies. Prior to that, I had a couple roles at Dolby. I was the head of content production engineering for both Dolby Vision and Atmos. I was responsible for integrating SDKs essentially into third-party software tools to produce Vision and Atmos, as well as supporting post-production facilities. And prior to that, I was in charge of the OTT strategy for Dolby Vision, helped launch Dolby Vision with Netflix, Amazon, iQIYI, Tencent, and a bunch of others. And then before that, I was at DirecTV, responsible for OTT and DRM systems architecture. So show of hands, how many people here sort of understand why HDR is a big thing. Okay. So I won't, touch too much on it, but effectively, right, most of our television standards basically date back to when everything was a cathode ray tube and a vacuum tube. Even when we went to ATSC 1.0 and went digital, a lot of stuff was legacy to basically analog television. All right, so even when we went to HDD, we were still in a world where all the displays were phosphor-based, and so all of the limitations of phosphor displays were inherent. And as time went on, the displays and the cameras could capture more color, right? Way beyond what the signal basically designed for ATSC 1.0 could carry. So there came a time where essentially the entire lens-to-lens improvement was there, right? Like the cameras could capture more, the displays could show more, but the signal couldn't carry it. So we were in a situation where the displays had more pixels, right? So we were going from HD to UHD. We had faster pixels. We were increasing the refresh rate. And then a lot of folks started asking, well, why don't we also just have better pixels, right? So more contrast, essentially more dynamic range, more color information. And so rather than introduce an entirely new standard to do HDR, people like Dolby and others, BBC, NHK, decided that what they would do is create new standards that were built on top of the existing proposals for how you would do things like ATSC 3.0 or the new versions of DVB. Right? And then in the streaming world, right, it was just make everything work with Dash and HLS. So from a standards and codec perspective, right, like primarily HDR lives in the HEVC AV1 world. There's support in VP9 as well for some forms of HDR. It's an optional format in ATSC 3.0 as well as for DVB. Any questions so far?
Just know this is not an official logo of the HUV system.
Yeah. I didn't know if there was an official logo for HEVC. Yeah. So originally I was going to talk about the differences between the different HDR standards as EOTFs, or the electro-optical transfer functions. But really what it comes down to is there's a difference in how the pixels are actually recorded and then presented. So we have effectively at this point 2 camps for these pixels, right? One is HLG, so gamma pixels effectively, and then all the other HDR formats are PQ-based, or perceptual quantization pixels. So for HLG, HLG was primarily designed by BBC and NHK, and their intent for the format was to have an HDR format that was backwards compatible with SDR. So they didn't want to broadcast 2 signals, right? In the early days of HDR, we were still talking about this in terms of broadcast standards. So both the UK and Japan wanted to broadcast a single signal that would work with both new HDR TVs as well as older standard dynamic range TVs. And hybrid log gamma was the solution. So effectively, the way that this works is that it's still using gamma, but doing effectively like a soft knee logarithmic portion to the gamma curve. So part of the gamma curve is readable by SDR TVs, but it is in no means actually the full potential of the SDR signal. So the backwards compatible signal for HLG is actually slightly worse than an actual SDR signal. And then you build on top of that to get to HDR. So in many ways, this kind of works like Sony S-Log. No big surprise, Sony was pretty active in the commercialization of HLG from an equipment standpoint. So one of the big things to know about HLG is that it's a royalty-free standard, but it's not open source, right? And we'll get into why HDR10 is truly open source. So all of the IP around HLG belongs to BBC and NHK, and they've made it available for people to use with no royalties, but you still have to get some kind of licensing to build equipment to support HLG. The other big distinction between HLG and PQ HDR is there's no metadata at all. It's a scene reference-based signal system. It's still gamma, and like as I said, it's backwards compatible. So any questions on HLG?
Well, okay.
Yeah.
How many bits deep does an HLG master need to be?
So the official HLG standard mandates that it has to be a 10-bit signal.
Okay.
Yeah. So, yeah.
Why doesn't have metadata at all?
So from my understanding is from both BBC and NHK is that at the time that they designed this, they did not want to include the complications of metadata for live. All right, so they wanted a system that could flow through a live facility with no real changes to most of the equipment. So by not having any metadata, they don't have to worry about those complications, right? Yeah.
So by not having the metadata, it like prevents things like jitter?
So the metadata, especially in the PQ formats, does different things, but it's primarily used to tone map on playback. So there's not a lot of benefit, I'd say, on the acquisition side to metadata. It's all on the playback side. And especially as you're talking, the HLG was designed for live, right? So the idea is that it's scene referenced in the same way that NTSC and ATSC, which is basically assuming that if your display has the same capabilities as your camera, you're going to roughly get the right image. If there's a deviation, then the TV is going to have to tone map and you'll get a difference from the intended image. But I'm speculating thinking that at some point, right, the display capabilities will catch up with the TV and therefore you have a system that's balanced and the images look proper between the two. Andy, you were going to ask a question? No? So then the other camp that we come to, which is predominantly all the other HDR formats, is PQ, right? So pretty much every other HDR format is some derivative of PQ. So the pixels between HDR10, 10 plus, even Dolby Vision in certain cases, right? Even Technicolor and Philips' system, which is now being merged, are all the same. If you have a 10-bit version of all of these, the way the pixels are represented are identical. The difference really becomes the color space they're operating in and the level of metadata that they have. And so PQ fundamentally is different than HLG. So the gamma signal in HLG is a linear code value. So if you have 10 bits, all the code values for those 10 bits are evenly distributed across the whole dynamic range. The big innovation in PQ is that the code values are assigned to what is perceptually more sensitive to the human visual system. So the idea was that like in the midtones and in the areas where the human eye and the brain can perceive the most amount of detail, you're going to stuff most of the code values in that range, right? And then you're going to, as things get brighter and you can discern less detail in bright areas, especially in whites, you have less code values. So, the PQ camp will argue that PQ is a more efficient way of encoding information. At Dolby, what we used to say from our testing is that a 10-bit gamma signal, right, had X amount of dynamic range. A 10-bit PQ signal was equivalent to a 12-bit gamma signal.
Okay.
Right? So PQ, in essence, gives you about 2 bits performance advantage over gamma. So in 12-bit Dolby Vision, you're effectively getting the same as 14-bit gamma in terms of resolution for dynamic range. So, any questions on that? Okay. So all of these companies have decided to basically use PQ because Dolby took this research around PQ and standardized it in SMPTE. So a lot of times what you'll hear in HDR talk is right ST2084. So that's the actual SMPTE standard for how you do PQ. And that is effectively open source, right? It's a published standard, there's no royalties. You don't have to sign any paperwork with anyone to use 2084. Then the other thing that Dolby did is they standardized the static metadata for how they were going to do Dolby Vision, and that became ST2086. And effectively what that tells you is what is the max average light level, right, for the whole piece of content. It's not scene specific, it's for the whole piece of content, right? What's the maximum content light level, or peak white, effectively, for the whole piece of content, as well as mastering monitor data. So you have to know what the mastering monitor, so what monitor was actually used to create the content, right? You need to know what the black level performance is, what the peak brightness and the color gamut is. So all of these components right here are effectively published and anybody can use these, and hence why you see HDR10 on almost every device, It's a fairly simple formula for how you build an HDR format. The challenge that comes with having a system that only has static metadata is that metadata is not very useful for tone mapping a movie or a TV show. Because you're taking you could argue the best case or the worst case scenario for the whole piece of content, and you're not able to do scene by scene tone mapping with any adjustments or look ahead beyond the TV looking at only 2 or 3 frames. Right? So the challenge that comes from the playback device side when you have static metadata is you could try to do a really deep analysis of the frames, but then you're introducing more latency, so the SoCs need more RAM. And in the TV world right now, they're fighting for pennies, right, to reduce the BOM on a TV. So having some kind of dynamic metadata becomes your roadmap for how you do your tone mapping. And so that's really why you're seeing most of the industry moving to one form or the other of dynamic metadata. And that's where we get to SMPTE 2094. So there's a lot of confusion around this. Unlike 2084 and 2086, 2094 is not a full standard for how you build these different HDR formats. It basically describes them all at a high level. And then you have to go to each of these individual companies to get the actual implementation technology to put in your display or to encode properly.
Including dash 40?
Yeah, including HDR10 Plus, yeah. So effectively what you have is, so the first one, right, that was published was how you do Dolby Vision with dynamic metadata. One thing to know as well is that all the other systems are 10-bit, right? Dolby Vision supports both 12-bit and 10-bit. So there's the one big distinction between all of them. 2094, 20 used to be a Philips standard, and 30 was a Technicolor standard, but they're merging them together into one single standard called SL. And then HDR10 Plus, right, which is primarily driven by Samsung, but has some other companies that participate. And 10 Plus, while royalty-free, is not open source, right? So HDR10 Plus Technologies, LLC, will allow somebody to become a licensee without charging them any money, but it's not the same thing as HDR10 where you can just build your own solution. And this is the same case for encoding the video as well, right? So you have to get some components from them to basically do the SEI messaging for HDR10 Plus. Same thing for Dolby Vision. You can't just encode Dolby Vision on your own, right? You do need some components from Dolby to be able to do their equivalent of an SEI message called an RPU and to do some additional metadata calculations at the time of encoding. Okay. So any questions on the differences between the two formats?
What's the likelihood of 12-bit adoption?
So Dolby Vision is inherently already 12-bit.
I mean, from devices?
Yeah. So the signal is 12 bits, right? The display technologies are not yet 12 bits. So most of the panels are 10-bit or 8-bit with, usually 8-bit with dithering or 10-bit with no dithering, right? So there's not really a display yet that does the true 12 bits, but the signal and the content is 12 bits.
Yeah.
Yeah.
I guess I was asking about the devices specifically.
Yeah.
What?
Just
So,
your thoughts on what you think, whether people will adopt.
So it's a question of whether or not the panel manufacturers want to invest in adding an extra 2 bits to the panel resolution. It's hard to say right now, right? Like they're really focusing right now on other areas, right? They're more pixels, basically, right, and faster pixels. They're not investing too heavily at the moment into increasing the bit depth for the panels, and even to some extent, gamut is still an area that they fall pretty short, right? So like higher end TVs might hit P3 color, but like lower end TVs sometimes struggle just to hit 709, which is the color gamut just for HD. So yeah, you had a question? No? Okay. Sure.
I had a question, like, on the content side. Is there, I know there's quite a bit of Dolby Vision content. What about HDR10 Plus? I understand there's been some content and some content providers who've come out and said they're going to use it. I know you're not Dolby anymore, but the Philips Technicolor blended thing that's combined, any content that's been generated serious Hollywood content, for example.
So from Hollywood, no. Right, and I'll cover that actually in my next slides of like the devices and then the content landscape and sort of where we are. But I'd say that right now for Hollywood content, the primary mastering mechanism is PQ, and then they're layering the metadata on top of it to support things like Dolby Vision and HDR10. But I think of all of these, the Philips and Technicolor solutions have the least amount of content, but have a surprisingly high amount of device support. Yeah, so here we get to the slide then. At least from a TV perspective, right? Who's supporting what effectively? And from my take, a large part of the HLG adoption is because devices have to operate in Europe and in Japan, and that's mandated for the broadcast. And so you see a lot of repurposing from NHK and BBC of their content directly in HLG for streaming. Right? They're not taking their HLG broadcast and reconverting to HDR10 or Dolby Vision. They prefer to keep it as HLG. So a lot of devices support HLG because large CE companies are operating in those countries. Then you have a slightly misleading HDR10 Plus device ecosystem because I forgot that Panasonic has now adopted 10 Plus. So you have Samsung and Panasonic displays. Almost everybody supports HDR10. The way that HDR10 is playing out is that the TV manufacturer themselves doesn't even have to do the HDR10 implementation. The SoCs that they use, usually from third parties, almost all of them have some default HDR10 capability. And then, like in the case of Samsung or LG, their in-house SoCs, they'll add some other logic to it. But for most TVs use third-party SoCs at this point. Only some use in-house, and in that case, they add it. And then you have quite a few devices that do Dolby Vision. And so, it's really like if you look at it from a pixel perspective, right? Most devices support PQ pixels, and some support gamma pixels for HDR. And then to your point on the content side, at least from the movie studios, when they're going for theatrical release, because this is another component that's not often talked about, a lot of the content that ends up being used for HDR originates in HDR cinema and then has a home HDR grade. They don't translate directly. So if you do a color grade for HDR cinema, it doesn't actually translate directly to home. You have to expand it. But still, pretty much all the majors, right, ourselves and Amazon and Netflix are creating Dolby Cinema titles, which are effectively just PQ 12-bit titles. One thing that's often not discussed is there's no metadata in Dolby Cinema. So Dolby Cinema is truly just a PQ format with zero metadata. Go ahead, dear. Yeah, well, the part of it that is proprietary is the projector, right? So it's a PQ signal that's basically created on a Dolby Cinema projector, so it has to be projected on that same projector in order to be accurate. And then this is the landscape that, for when things become created for home delivery. And so, you have, to your question about HDR10 Plus, you have quite a few studios that are basically creating HDR10 Plus masters from their PQ source, right? Including Amazon, right? And 20th Century Fox, WB is doing it, Universal. And then you have other people who are taking those PQ masters basically at the 12-bit stage, therefore they have Dolby Vision. But the metadata, for the most part, is basically just a layer on top of the PQ pixels. So when you're creating the content, whether you have a 10-bit or a 12-bit PQ signal, it's up to you as the content creator to decide whether you want to create the Dolby Vision metadata or trims in Dolby Vision as well, which are just offsets to the metadata, the 10 metadata or the 10 plus. The pixels themselves are identical between all three versions at the content stage. At the encoding stage, there are some differences, but at the content stage, effectively, what you have is a PQ master with multiple types of metadata. Yeah.
You show Fox outside the Dolby Vision circle, but aren't there a lot of Dolby Vision Fox Blu-ray discs?
So this is why I have a question mark around Fox. Prior to the acquisition of Fox by Disney, Fox was actually the one major in Hollywood who was not supporting Dolby Vision on any form. All right, so they were mastering everything in HDR10 and they were only delivering in 10. They signed up for 10 Plus when 10 Plus became available, but it's unknown what's going to happen now that they're part of Disney, because Disney is actually very pro Dolby Vision. And so if you look at the camp of studios that do both Dolby Vision and 10, what they basically do is master in Dolby Vision and then create their HDR10 from their 12-bit Dolby Vision masters in most cases. Now, when it comes to broadcasting, this is interesting because all the formats originally were designed for broadcasting. When I was at Dolby, it became very obvious very quickly that we were actually going to deploy Dolby Vision in OTT long before it was going to get adopted in broadcasting. Right? But broadcasting was originally the primary market for all of these formats, with this opportunity of going to UHD and basically adding HDR right to the new standards for both 4K, the fact that we had 10-bit codecs, right, and other advanced features within the displays. So you actually, if you look at the HLG support from broadcasters, it's pretty large, right? Not a lot of broadcasters right now are transmitting in either HDR10 or Dolby Vision, mainly because most of the broadcasters really are, Japan and the UK, and then the countries that they influence for broadcasting standards. And so obviously you have BBC and NHK up there. DirecTV, this is a little bit out of date, has done HLG, but is moving to basically supporting PQ. But yeah, right now, most of the broadcasting is happening in HLG, but most of the content that's post-produced is being done in PQ. So from a broadcasting perspective, what we really have is that for, let's call it post-produced content, PQ is being converted to HLG for transmission, right? And typically only in live events is HLG actually end to end. So sporting events, especially because, from an HLG production standpoint, Sony owns most of that market. A lot of their TV cameras support a native HLG mode. Their switchers support HLG, so you can have a full HLG workflow for live. For post, it's a lot different, right? You can have cameras that support HLG or Sony S-Log, but when you're going for cinematic content or high-end episodic content, it's usually shot in RAW, and so it's independent of the EOTF. And then you see the Philips camp there. So one of the reasons Philips and Technicolor actually have such a large footprint is they have a pretty large set-top box business, and they just added it to all the set-top box that they manufacture for other companies. So there's large installed base for SL, but not a lot of content yet. And then it looks very different, right, for streaming services versus broadcasters. You have a lot of double support, right? So there are many streaming services that support both, right? Dolby Vision and HDR10. Currently, I believe Amazon Video is the only one that supports all three of the PQ minus the Philips, right? So we support 10, 10 Plus, and Dolby Vision on a limited basis. And then YouTube has decided to support HLG as well as Vimeo. YouTube, I believe, has also added support for HDR10, though. I don't know if Vimeo has. And then you have quite a few services that support Dolby Vision, especially outside of the US. It's very strong in China, for example. So, any questions on this slide? Yeah. So I think from this, I just open it up the floor to how much deeper you want to drill into either the technology differences between HLG or PQ, or any questions around devices or streaming services. So Yuri.
So what's going to happen in 5 to 10 years when display is going to be like 4K nits with big brightness, and where you don't really need to do any tone mapping. You will be actually making display more expensive and finicky if you even try to mess with it. So at that point, does the dynamic metadata still make sense, or shall we take a Phil Clough approach, basically?
Yeah.
Let's wait a little bit and
So in general,
and the problem will take care of by itself.
yeah. In general, the closer the display's capabilities are to the content, the less the dynamic metadata makes a difference. But we're still quite a ways away from that, right? Because in theory, so PQ supports up to 10,000 nits, right, in full 2020 color space. So there's no 10,000 nit consumer display. There isn't even a 10,000 nit mastering display. So from a mastering perspective, we had a 1,000 nit mastering display from Sony. There's now a couple other mastering displays from ISO and from Flanders that support close to 3,000. Dolby's got their 4,000 nit proprietary mastering display. And so currently most of the TVs struggle to get to 1,000 nits. But yeah, as the TV's capabilities start matching the color grading monitors, there's not as much benefit to the dynamic metadata, but there's also no harm to having the dynamic metadata there. The other thing too is that even though TV manufacturers will implement 10 Plus or Dolby Vision that have dynamic metadata, they still like to do their own tone mapping to give each TV set its own unique look. And so they still use the metadata to some sense, right, to like figure out what the image is doing and then tweak it to what they want.
You made the comment that there's no harm from the metadata, but it seems like if thinking end to end through the whole ecosystem, especially in the streaming case, that there is some effective cost in having to maintain the metadata transfer and then for the devices. Can you speak to that at all? Is that just a unreasoned concern, or is that?
So for live, there's definitely complications in trying to flow metadata through the whole pipeline. In live, what they're doing is they're basically producing either an HLG or PQ, and if they're going to be broadcasting out in 10 or 10 Plus or Dolby Vision, they're doing the image analysis at the end of the signal chain and adding the metadata prior to transport, right? From the VOD side, the metadata is there in the mezzanine, and then effectively, in the case of HDR10 Plus, you take the metadata and you package it into the SEI message. With Dolby Vision, there's some additional metadata that's generated at the time of encoding to do things like describe parameters for global dimming backlights versus local dimming backlights. But the payloads for that metadata is very small. I mean, we're talking like 10, 20K, right, per scene in some cases. So it's not a high overhead. On the VOD side, it's also not very complicated because, again, everything is taken care of basically at the time of encoding and when you read the mezzanine. But there is a lot more complication in live. So as far as I'm aware, nobody's trying yet to flow metadata through the whole pipeline from camera through signal processing and then transmission. They're only adding it at the last step.
Yeah, maybe it's assumed, but I don't know too much about the HDR landscape. Could you talk about consumer perception? Can consumers tell the difference between HDR and non-HDR, SDR, and what's the relative value to consumer for an HDR TV or online experience?
So I think, this is my personal opinion. I'm not speaking on behalf of Amazon or Dolby. So this is a really complicated question because if the question is like, what is more faithful to the original source? I would say universally, all HDR formats get you much closer to the intent of the content. And then when you have dynamic metadata, it's even more so. But that requires having a reference. So there were a lot of demos that we used to use at Dolby where you would have a reference image, basically the mastered content, right, against the HDR display with metadata, and to show how the tone mapping, even on a display that deviates a lot from the mastered display, preserves the overall look and feel, right, of the content. The challenge with SDR right now is that nobody's actually looking at SDR how it's intended to be viewed. Pretty much every TV that you can buy, whether it's a cheap TV or $3,000 or $4,000 TV, exceeds the signal capabilities of SDR. So they stretch the content. Right? So SDR is technically defined as 0 to 100 nits and Rec 709 color space. But if the panel, say, gets to like 96% of P3, has 500 nits, they will actually stretch the signal to maximize the amount of brightness that the TV can do, right, and expand the color gamut. And every TV has its own strategy, right, for how they expand SDR. Then you also have like vivid mode and gaming mode and sports mode. So that's oftentimes what happens is customers, right, are accustomed to how content looks, let's say in vivid mode from SDR. So like, overly bright, saturation's punched up, right, contrast is, exaggerated. And then you show them a very realistic HDR image, and they may just prefer, right, the overly processed SDR to the HDR. And other customers like absolutely love the HDR image. It's really tough. And so right now, like from my side, or my personal opinion, HDR is really being driven by the creative community because it does expand the capabilities of the signal, right? And the HDR ecosystem in general, right, really represents what's capable, from the content side. From the consumer side, I don't think there's any definitive studies that I'm aware of that show like consumers prefer, right, HDR versus overly processed SDR, et cetera. But it also just doesn't matter because all the TV manufacturers are putting in HDR into their devices, right? There's a lot of mobile phones that are, by default have HDR in it. And I don't think that feature is going away. I think what may happen is that some of these formats may go away in time, but there will always be some HDR, format that stays. Because I don't know for how long you could have a world with, say, 4 or 5 different HDR formats. Like, there might only be room for 2. Right?
Just more of a comment, but I was going to mention that it makes me think of that video that came out with Tom Cruise and the director of one of his recent films, basically saying, "Turn off the freaking True Motion on your TV, people. It's ruining everything." But it's on by default. You buy 9 out of 10 TVs, it's on by default. And I can't tell you how many of my friends' houses who, they're not in the video industry, but they know what they like. And I go over to their house and they've been watching stuff in True Motion for 5 years. And it's like, this looks awful,
Yeah.
And I just wonder if, that was one of the first thing I've seen in the creative community that actually got a massive, millions of views, and people are like, oh, I should turn this off, but it actually reached like mass status from a viral standpoint, and the average user in Iowa actually probably saw that video and was like, maybe I should turn it off. And but it took that, and I wonder if the same thing is going to be required for HDR standards. Not be required, but it's just like the amount of effort that goes in the entire mastering, not only content creation process, but mastering process to create everything we're talking about here. And it's I don't know what the percentage is, but a significant amount of it is almost negated completely by the time it reaches the glass in the user's living room. So it's an interesting. I don't have an answer, but I just brought up the Tom Cruise True Motion thing, and I thought it was an interesting connection.
I mean, I think from the consumer perspective, especially on TVs, it's a huge problem. Interestingly, with mobile devices, it's not as big of a problem. For whatever reason, right, where tablets and phones, they've chosen to actually display SDR fairly realistically. So actually on those devices, when you look at HDR, there's a more, linear improvement to the signal. It doesn't look as different. Now you just have this enhanced capability to the signal. But on TVs, it just varies all over the place, right? Because, again, you could be in vivid mode, gaming mode, whatever. There's roughly something like 70% of people never change the default mode on their TV, right? And the difference there being is that the default mode for SDR is a different default mode than HDR. So they will look different. So yeah, it's a universal problem. I think it's up to everybody in this industry to try to help educate consumers. But I don't see a world where HDR goes away, and I just think inevitably all the content's going to be produced in HDR. And it'll just be legacy content in SDR. Yeah.
I was going to ask this as a question. I do have another question as well, but I don't know, for those who didn't read the BBC article that was put out after their first pass of live HLG broadcasts was absolutely fascinating reading because the general public hated it. They declared it to be too dark and too bright in one picture. They declared, these scenes that were shot in the studio with the presenters were beautiful. Those were being upscaled to fake HDR, while the actual football game and the tennis games were true HDR, and they were generically hated. Because again, the exact same problem, the SD content is being, kind of fake, brought up in brightness and contrast and saturation. It makes it look wow, whereas when you're looking at a green field, and this was a problem on both the football and the tennis, was part of the pitch was always in shade. So you've got this really bright, really green, not super green piece of the pitch, and you've got this really dark thing. When you actually represent that faithfully, it looks really bad for a lot of viewers. But anyway, that was a little side story. The write-up BBC is worth reading on it. Second question was going to be, I wanted to mention this monitor Apple is bringing out, the infamous, very expensive monitor. I've talked to a variety of people. Some people claim it is perfectly fine to master Dolby Vision, and other people say, no, this is not ready for grading proper content. Do you have a definitive answer on whether that monitor is going to actually grade Dolby Vision or not?
So I can tell you, because this was an area that I actually had a lot of responsibility in at Dolby. Dolby does not approve mastering monitors, right? So this is a misconception in the market. Dolby is partially responsible for this. So it doesn't matter what monitor you use to create the content for Dolby Vision, but what you do need to know is what that display's capabilities are for the static metadata. So you do have to have an accurate profiling of what the black level is, the peak white, the color gamut, et cetera, right? Because that has to be recorded in the static metadata to basically make sense of the picture on playback. And that's the same for HDR10. It's for any PQ. I mean, technically speaking, the Apple display is a consumer display, right? It's not built and designed to the specs that color grading monitors are built, right? There's a reason they cost $40,000 to $100,000, primarily because when you look at serial model 100 and then 10,000 down in the production line, there are going to be very tight tolerances between every single one that comes off the line. Consumer displays, even very high-end ones like the Apple ones, are not usually held to that high standard. There are some very color-accurate professional displays like ISOs that are meant for computers that are being used for color grading, but again, they cost like 35 to 50 grand. But that's not to say you can't use it, right? What's that? Yeah, I mean, Jens can speak to that. I mean, why don't you?
Well, Amazon, Studios, I approve all the monitors what we use for mastering, so each one is evaluated for mastering, availability, cost, and ultimately the colorist experience with it. So things like the ISO, anything that's limited on HDMI is no good. You get banding. Resolution is really important because we want to look at it in full 4K pixels, unfortunately for Dolby. And you don't work there anymore, so I can talk about it. But generally speaking, it's up to the individual studio to decide what's right for their studio. So independent projects will probably use prosumer displays, but most of the major studios will move and they'll stay in the Sony range. They'll go with Dolby monitors. The workflow generally with the Dolby monitor is that they do part of the work there, but then they take it over to like an X300, the Sony monitor, to review the 4K, right? So like they still want to see all the pixels at some point, or they'll do most of the work on the 4K and then go over to the Pulsar. So there are multiple ways of doing it right now. But generally speaking, you want to see all the color as bright as you want to get and all the pixels at some point to make sure that you're not adding artifacts and that you can see all of the things you want to see. So for Dolby Vision, at some point, you want to look at a Dolby Pulsar.
Brian, thank you very much.
Thank you.
Awesome presentation. Okay, and our last presenter tonight is Yuri. Brian, are you hanging around for a bit?
Yeah.
Yeah,
Till
cool.
the end.
Whenever that is.
That's a good sign. And it goes to thank you. That was brief.
Your microphone on?
Is this one right? Okay, can you hear me? Okay, very good. Thank you very much. I'm Yuri Reznik. I'm with Breitkopf. I run research group, and I'm going to show some formulas, but I'll try to not to dive too deep into it, and try to use simple words to explain what I'm doing, and hopefully it will be understandable. The outline of the talk is as follows. I'll talk about multi-codec streaming. And before I start talking about multi-codec, I'll introduce some basic concepts, things like what is IBR streaming, models of codecs, streaming clients, ABR ladders. Last time here I spoke at length about CDN performance and streaming. That is kind of relevant, but I'll skip details. And then I'll talk about design of quality optimal ladders for ABR streaming. And we will look at example case of using single codec design, which is simple and well understood by these days. And then we'll look at a system with two codecs. And that will actually have very interesting connection to what is known in information theory as multiple description coding problem. But so there will be a little bit of fun on theoretical end. But then last few slides will be devoted to what it all actually means in practice, and I'll talk about what's actually implemented, deployed, and give some real-world examples. So let's start with ABR streaming. Basically, in present world, we're talking about, in present time, we're talking about HTTP-based ABR streaming delivered by means of protocols such as Dash or HLS. And what usually is done in these cases is that content is encoded at several bit rates, right? Then each bitrate stream is called rendition. Usually, the composition of those streams is usually called ladder. Then each of the streams is chopped in segments such that clients can switch between those streams at segment boundary at certain interval, which is typically segment length, which is could be 2 seconds, 6 seconds, and so on. Fairly fine-grained switching, I should say, and then content, which is a composition of such segments plus a manifest file declaring all of them, goes to origin server. And from that moment on, delivery and scaling is done by CDNs, which of course is a highly scalable and cost-efficient way to do things, and conceptually simple, which is important. And then the logic of actually pooling these segments, understanding what current bandwidth is, and then deciding what of the next streams to pull next is happening on a client. And this way, clients could predict bandwidth, and if they see that there is, for example, one stream at 1 megabit and another stream at 2 megabits, and the bandwidth is already 3 megabits, then perhaps it's time to switch to 2 megabit stream, because you could pull it at this bandwidth reliably, and the quality will be better. So the idea of clients is to deliver uninterrupted performance and good quality. So it works somehow in most of cases, and the objective of the talk is to kind of think about what it is and how to design it optimally. So some basics. Of course, what usually is an input for streaming is the content. The content could be of different complexities. It could be, for example, cartoons. It could be high-action sports, and you need totally different bit rates in both cases. With cartoons, you could encode them at 1 megabit at 1080p. It looks fantastic. With sports, maybe 10 megabits is not good enough, depending on a kind. Codecs, nowadays. There are many of them, and they differ in efficiency. For example, HEVC in most cases is considered to be better than H.264. AV1 and VVC, which is coming, are even better. I heard recently that AV2 is going to be coming next. So the world is going to be even more merrier as time goes on. And what is important is that the difference between those codecs are also content dependent. So for ultra simple content, perhaps H.264 and the difference between H.264 and HEVC is not that significantly. For complex content, it could be a totally different story. And same with others. And if the difference is significant, it's great. It makes sense to switch to the codec. If the difference is not that significant, we are in gray area where we really need to think. Now, there are also many different quality metrics, but actually none of them is really good. So there are very simple things like MSC, PSNR, which basically measure average amount of noise. SSM does normalization of this noise by local energy, which basically maps it in domain of contrast or contrast sensitivity, which is a unit that is more closely mapped to mechanics of human vision, but it's still very basic and nowhere close to realities of how perception works. VPD, visual difference predictor, and PQR, which is a Tektronix metric based on old Lubin's model. Those are kind of more advanced metrics, but you need to either invest time in developing them or pay a lot to Tektronix to use them. And then, of course, there is VMAF, which fuses several basic metrics, but it's still work in progress to best of our understanding. It works in many cases. It actually fails in some others. For example, if you have clean input and you're comparing against your output, the results are more or less okay. If your input is bad, VMAF could be arbitrary, misleading in terms of what it tells you about quality. So now, but regardless of which metric you're using, codec and content, if you take the triple of all of them, you actually can characterize performance of that system, and that is done by basically quality rate function. What is quality rate function? Is basically you encode video at several operating points, and then you connect those points by a certain model to say what is the space of achievable regimes or operating points could be. And in the example on the right, I'm showing an exercise where I took cartoon-like content as well as a complex sport type of content, and they encoded them with H.264 and HEVC at about 5-6 points at CRF, and then I connected them with very simple models that is shown below with 2 parameters, and you see that that model actually fits pretty well. And so this is kind of what you could say about content plus codec plus metric. You could just create models that tells you what is the space of achievable trade-offs is if you encode it. Now, another thing that you need to quantify if you're trying to design system optimally is you need to understand what is the model of network. And to understand what network you're working with, you really need to start with logs, either from players or CDNs. Look at statistics. For example, below I'm showing histograms of bandwidth collected by Brightcove Analytics module, and then you could also model them. So on the right, again, it's a theoretical example. I took measurements of network from LTE network with 2 different types of loads, and thrown a mixture of 2 array length models, and there are 3 parameters, and it actually fits pretty decent to the experimental data. But again, important thing is that information about important information for design of ladder about network could be actually reduced to network model, and that is basically distribution function. It tells you what is the probability that your bandwidth is X, and for example 2 megabits or 1 megabit or 10 megabits. And now, last model that we need, and that is a model of a client. And a client, of course, is switching, right? And it is switching based on bit rates that are available on the ladder. And it is switching such that giving the available bandwidth or estimate of available bandwidth, it tries to pick bit rates that will be sustainable, such that you could load rendition at that bit rate and you're not going to run into buffering. So the simplest way to think about it will be to say, okay, well, if ladder will pick the highest bit rate that is equal or below that available bandwidth, that will be sustainable regime. And that's a viable approximation of client behavior. Of course, in practice, it's much more complicated, but this simple model actually works for the purposes that we will be using it for. And there are two ways to think about it. The first plot shows the selection of bitrate based on available bandwidth, and the right plot shows what happens with achievable quality in that case. So it basically, from a continuous quality rate function, which is sigmoid type of function, right, we end up with a staircase approximation of it. So effectively, we're quantizing that quality rate function to n points, which becomes our ladder operating points. But now, if we know this client model, right, and that is R selected of R as a function, and we know network models, then we could, of course, describe what would be the average bit rate that a client is pulling during the streaming session and the average quality. These are shown here. It's a simple integrals. Of course, in practice, if you work with histograms, those become sums. But you know, the models could be you know, functions with some mechanics in them. But this is a basic concept. Now,
how did you measure the quality over there?
so.
From the selected bit rate, you're showing that
Right.
the quality.
So quality rate function. It was just a second. It was here. So basically, pick any metric you like, encode your content at several operating points, and then fit that with a model that will predict you what would be the quality according to this metric for this content and for this codec that will be achievable at that bit rate. So it's a model that gives you a space of all possible achievable.
The qualities are not subjective qualities. Qualities are based on those models. Which model you choose.
Exactly. It's which metric you choose.
Which metric you choose.
It actually could be objective quality. You could actually do a MOS score, and you could record. So those points that I'm showing here, these are experimental points that you put, and then you fit a curve of any suitable shape that fits them well. And that gives you the input to the algorithm. So in this case, the model is actually the sigmoid type of function. It's actually one of the classical sigmoids used in exam dynamics and neural networks and similar areas. So it's a very kind of standard sigmoid model. But it fits pretty well for SSM and codec behavior. Now, so that gives us quality numbers, and then we plug in client model, and we get estimates of average rate and average quality. So what we can do next with this? Well, now we could kind of think about whole streaming chain, and of course we start with source, and it goes through encoder. After encoder, you have a ladder, right? You have endpoints with rate at each and quality at each, Ri, Qi. So you have pair of numbers there. And then you go through a client, which effectively does rate selection plus decoding. And as described previously, from that client model, we could express average rate and average quality that goes to the end, at the end of the system. So those average rate and average quality is average quality that's delivered to the user at the rate that was consumed from network. Now, if we think about it this way, and we have all the models in place, then one problem then can be immediately posed is, given certain number of rendition n, quality rate model, network model, what would be the set of rates from R1 to Rn such that the quality that will be achievable by the system is maximum? Why there will be maximum? Well, because we are balancing between two things. We are balancing between probabilities of how many viewers will be watching content versus the rate and quality that's achievable on each. So there is a pretty strict optimality point in that situation. And in fact, if I throw all the models that I was showing before to Mathematica and run maximize, then this will be the ladders that I obtain as a result of it. And what we can see is that for easy content, of course, the bit rates will be different than for complex content, right? HEVC bit rates will be generally slightly lower than H.264 bit rates, right? And if we repeat this exercise for network 2, the results will also be different. So that really tells you that this is an optimization problem, and you really need to take into account both content, codec, and network as inputs. You can't solve it optimally if you disregard either one of them. So it's this is where we stand. So this is optimality problem for first for a single codec system, and you could design it for either codec. But now what's going to happen if we start looking at systems with two codecs? And I'll spend most time on this slide, actually. So consider a system where we now have two codecs. There is H.264, and there is, for example, HEVC. And of course, there will be clients that can decode H.264. Most of clients these days can decode H.264. Some clients can decode HEVC, right? And some clients can not only decode HEVC, but they also can switch between HEVC streams and H.264 streams seamlessly as they pull streams. So you could, and one good example of clients of this kind is actually Apple devices. So all new Apple devices, iPhones, iPads, you throw the mixed ladder renditions where some of them H.264, some of them HEVC, they will switch between them. And they will switch seamlessly. And what it means? Well, if device can decode only H.264 or only HEVC, then of course they will be dancing along the curve of that corresponding codec. For example, green curve here shows HEVC, red curve, it's a quality rate curve, shows H.264. And then the point that, for example, HEVC only device will be picking will be only green points. It will be switching from this point straight to another HEVC point, and so on. But if it only switches between those points, it might actually be missing something. If we design ladders, both of these ladders, in such a way that you put renditions of H.264 streams in between two HEVC streams, and you place that point wisely, there could actually be intermediate reconstruction level that makes sense. It will be better quality at a better rate, but not quite large gap compared to case when you are switching straight from one HEVC rendition to another HEVC rendition. Why is this extra switch is helpful? Well, because then you can approximate network behavior better. You could stay closer to actual network bandwidth as it is available. You could pull more bits and deliver better quality when it's needed. Well, now, of course, you might ask questions. Why in the universe this is even possible? Or when it is possible that you have two codecs and you still have those intermediate steps that make sense? Well, it is possible when the difference between these codecs is not that big. For example, if this will not be HEVC, it will be VVC, and the gap between codec is between rates of two codecs is factor of 2 or 3 then probably there is no point of switching between them. There will not be any more intermediate points that will be meaningful. But if the gap in performance of the codecs is not that significant, if it's like 20%, it turns out there are a number of useful additional operating regimes that could be found out. And if there is the category of devices that can switch between those codecs, they can utilize it, and they can achieve better quality using fewer streams.
So this third type, is that practically being is the third thing practically being used?
It is
in the
Apple
world
devices.
Right, Brightco?
Apple devices.
Apple devices. I understand Apple
Right.
devices can do that, but are people doing that? Are they writing applications where they are switching the ladder? They are switching the codec between the ladders.
Precisely.
It is worth mentioning Apple explicitly say in the spec now, do not do this. The HLS offering guidelines say pick a codec and stick to it now. It used to say the codecs, the guidelines that Apple say in offering say don't do this. It used to say you may do this. It now says you should not do this. Within the last 6-8 months, they've changed it, and I don't understand why. I assume there is certain devices that have issues.
In practice, they work, number one. In practice, they work. Number two, actually, there is a growing class of devices that is switching, and actually the trend is to enable all devices switching. As you well know, there is an effort on MSC 2.0, which is enabling switching between different codecs, and we are entering in the world. There will be more codecs, and switching between them will be even more crucial. So let's see what Apple guidelines will say in another 3 months. Yeah, they had tendency of switching in the past. But as a matter of practice, in fact, all Apple devices can switch seamlessly, and it works pretty well. But there is another question, please.
Working in this way, do you necessarily compromise the optimality of the 264 ladder because you're adding another constraint?
So we will get to this. So it will be a joint ladder optimization problem where there was another question, right? No? Okay. Okay. So, but I just wanted to make sure if we understand what I'm talking about. Okay. So there is a way to create 2 ladders jointly such that there will be intermediate points allowing clients that can switch between codecs to operate more efficiently. And if we start exploiting this property, where we can go, and what would be the effects. So deployment model, the safest way to do it is to have edge support where there is a device detection, manifest filtering logic such that if device is understood to be a legacy device, only H.264 renditions are left. If device is understood to be a new device capable of HEVC but not switchable, only HEVC renditions go. And if it's Apple device, you leave everything there. And of course, mechanics of doing this with HLS and Dash are slightly different. In HLS manifest, you could order variant streams by bitrate, and that's enough for client to be able to pick them. In Dash, you should create separate adaptation sets, but then there is a supplemental property descriptors that you could use to say that you can switch between them. Now, this is the...
You weren't going to have a lot of equations.
This is very easy.
It's not going to be a test.
This is very easy. So I've shown a similar picture before where there was just one. Okay. There is a source, there is an encoder, and there is a client, right? In this case, there's still one source, luckily. There are 2 encoders, and there are 3 types of clients. And what is shown here is that after first encoder, we have first ladder. After second encoder, we have second ladder. In the middle, to the joint decoder, we have a union of both ladders. So both ladders are available. And what is shown as average quality is achievable. Formulas explaining what would be average quality is achievable at the end of each client. And Q sigma is actually the average, blended average of all those quality values with population parameters. So
you're solving for optimal dual codec
Exactly.
ladders in some sort of space where you're trying to find the local maxima.
Exactly.
In terms of quality in aggregate.
Exactly. Exactly. So the final aggregate expression is actually this weighted sum of qualities achievable by all clients, and weights are basically population weights or population probabilities. So P sub 1 is effectively fraction of clients that can only decode, for example, H.264. P sub 2 is HEVC, and 3 is a switchable codec. And of course, the objective is to find a mix of sizes of profiles that give you total number of renditions to be same, and then rates allocated to each codec such that the quality is maximum. It's a kind of generalization of previous problem. Now, the beauty of all this is that there is absolutely nothing new in this from mathematical perspective. It was all well known as a so-called multiple description coding problem in information theory. And in fact, there was even a paper by Azarov in the 1980s specifically studying systems with 2 encoders and 3 receivers. It looks exactly like what I just shown you before. With fewer formulas, but basically it was studied.
So did you know this when you did that, or did you, did you? Did you derive your previous idea from this?
No. Actually, it was differently. I solved that problem, and then I recalled that many years ago, I saw this paper, and that particular picture looked similar.
And you just happen to have it lying around on your desk. It's astonishing.
I was part. I was
AT&T 1980.
Exactly, it's a Bell System Technical Journal. So, but this is a famous problem, and the interesting part about it is that it is beautiful theoretical concept, and it had only periodic and occasional surfacing in history of people actually trying to do something with it in practice. And in most cases, it didn't produce anything useful, or there were found different approaches to do things more efficiently. Somewhat close to this problem is so-called scalable coding, but scalable is much simpler variety of it. So this one is more interesting. And but in this case, it sounds like we found application. And of course, the difference between theory is that in theory, the biggest point of amusement was the fact that if you do this joint decoding, then you actually could achieve quality or rate distortion trade-offs that are better than from 2 separate decoders. And that is usually described by so-called achievability regions. And usually the theorists stop right there. Their job is done at that point. We found that this is a fact. It's possible to derive better quality. Of course, in our case, we need to try to extract some utility from it. So this is why we connect all the outputs to a common output, look at the mixture of them, and try to run optimization on top to find out what would be the best ladders. And here they are. So this is network 1, easy content. Probability of devices that can decode HEVC is 0.4. Probability of devices that can only decode H.264 is 0.2. And the rest, which is 0.4, is the hybrid client. So that's the anticipated delivery scenario, which coincidentally is similar to what US looks like if we think about mobile. About 40% of Apple devices, and the rest are kind of split between legacy and the newer Androids. Now, what's interesting about it? Well, for easy content, turn out that if you try to stay with only few renditions, and try to deliver best quality, then up till the point when you have 6 renditions, if you only have like 5 renditions that you could encode, it turns out that using H.264 only is the solution. If you only have 5 streams, adding any extra HEVC streams is not going to help you on overall. But starting from 6 streams, it actually does help, and it does help quite significantly. So if you look at the bit rates that we achieve, at quality that we achieve at 6.6 streams with this mixed profile, well, it is equivalent to the quality achievable with 6-stream H.264 only profile, right? But then bit rate will be like 40% less. It's 1050 versus 1445. So this mixed ladder has dramatic utility. Or another interesting example, let's look at 7-point ladder and look at quality that's achievable there. So at 7 points, this hybrid ladder gives same quality as 8-point H.264 only ladder, fewer renditions. Plus, if you want to design just 2 ladders separately, you will design this one with 8 rendition, and then you will also need to throw 4-point HEVC ladder to match them. So you need almost twice number of rendition total to get to the same average quality as a mixed ladder in this case. And for complex content, it's actually even more dramatic. But one important difference that we notice right away is that with easy content, if you have only few renditions, H.264 only was the regime. With complex content, even if you have 3 renditions, it turns out it makes sense to start blending HEVC streams. And then the savings are quite dramatic. So for example, 5-point ladder with 3 HEVC streams and 2 H.264 streams deliver about same quality as 8-point ladder from H.264 plus 2-stream ladder from HEVC. So 10 streams total to
I got confused about what's the difference between Q-sub-n and Q. Oh, is this now working? Or are you you're tricking me? Okay, Q-sub-n
and average Q. Q-sub-n is a quality at the last rendition, and Q bar is average quality.
Okay, so that's the thing you're trying to optimize.
Yeah, I'm optimizing for average, but just for reference, I'm also including the quality up top rendition.
So I have a question here.
Yes.
If the quality level is coming out same, the average quality, right? Why not just use 2 separate ladders for H.264 and HEVC instead of creating a new one, new ladder, which is a combined one, and then write a complex manifest filtering logic?
Well, because you can do same quality with fewer renditions. Here with 5 renditions, you will achieve same average quality as you will achieve with 10 if you just design to optimal ladders for each separate codecs by themselves.
And the reason is that, I'm just trying to get your viewpoint. The reason is that because we cannot get away from H.264.
Because you cannot get away from H.264, and look, the difference in number of renditions is actually dramatic in terms of your encoding costs. It's also dramatic in terms of your delivery costs, because what happens with these renditions, they go to CDN edge cache, and they start competing between each other. And so the more renditions you have on edge cache, the higher the probability they're not going to stay there, and you're going to be pulling all the way from the origin, and you will be paying 10 times more for your egress costs. So it's really a long way how the reduction in number of rendition goes in terms of improving performance and reducing the cost of your system. So that's the utility. So quite dramatic reductions in a number of renditions, and that's just one utility that could be achieved. But of course, you could optimize it in a variety of other ways. You could look at your overall cost. Your final figure of metric could be very complex expression, including multiple cost components and as well as multiple quality components. Here I'm just looking at average as a simple mathematic model. So just for record, this was all published. You could find long papers on each of these topics. And now just a few minutes to say that it actually all works. And of course, it all works in Brightcove video cloud system, which is basically a end-to-end delivery system. It's cloud-based. It includes transcoder as encoder. It includes dynamic, what we call dynamic delivery system, which is basically transmaxing, real-time transmaxing, and manifest generation logic, CDN coupling, players, and it's all connected by analytics module. And what is important is that the information from analytics is used in feedback loop to CAE, and CAE is our context-aware encoding. That's the profile generator, effectively. So all these profiles that I was showing how to produce using Mathematica and some models, we actually have implemented as a operational piece of software that sits in the context of this system. And this is how it looks in practice. So you could pick one of the presets. It's called context-aware encoding, or you could write a JSON like a constraint set to this generator, where you could specify which codecs you want to use, what resolutions you want to use, other constraints. Network histograms can also be glued therein. So it's a pretty evolved JSON syntax of parameters that could be passed to the system, and it works. So I'll show a couple of results of performance of this system in two cases. So first case is we look at, it's the same content. It's a moving content sent to 3 different operators. So the first operator is in Asia, and it sends mostly streams to mobile, like 94%. And if you look at average bandwidth across all devices, it boils down to about 3 megabits. It's a very poor case of very poor networks. And the system is really struggling in many cases delivering data to delivering high quality video to this type of operator. And if you look at network statistics, they have huge peak at very low bit rates and extra peaks down there. The second operator is a US operator. It streams to a blend of devices. PCs take about 63%, but TVs about 20%, and mobiles somewhere in between. The average bandwidth across all devices is about 16 megabits. Of course, for TVs, it goes to 24, much more luxurious. And you look at the bandwidth distributions, they're, of course, much more spread. The third operator is an operator in Japan. It streams predominantly to TVs, and the average bandwidth there is 35 megabits. But if you look at the distribution, you see huge tail here going all the way to 100 megabits. It's wonderful networks. We can only dream about having these types of connections here. So totally different operators, but what we do is we send same content to them. We measure statistics and see what benefits will be if we apply CA optimization. So and CAE, of course, generates different profiles to all of them. And this is what you could see. So we save number of renditions to all of them, but remarkably to operator 3, which has best network, we save the most. We save like 44% in renditions. Effectively from 9 in standard HLS ladder, it went to about 4 or 5. And the reason being is that if the network is fantastic, it pulls the top rendition with 99% probability. The other renditions that you need to include in ladder is for conformance with HLS guidelines saying that you need to step in increments of 100%. Stuff like this. You still need to include the streams to pass a certain conformance test, but you really don't need it if you think about what is being pulled. But still. Now, in terms of storage, of course, the last operator has most dramatic savings, 68%. Actually, all operators have significant savings, well over 50%. Now, in terms of bandwidth, this is interesting. So for operator 2 and 3, where they had like 16 to 30 megabits of bandwidth on average, we save about 30-something%. But for operator 1, which had very constrained bandwidth, we can't save much. Why? Because even if we encode more efficiently, we pick resolutions to match its bitrate more efficiently, it's just going to eat whatever you give it. It basically pulls all the data to maximize capacity of the network. So we still save something. It's about 8%, but not as significant in the other cases. But then if you look at average resolution, turns out that net effect for this operator is very significant. We increase number of pixels by about 27%. So it uses slightly less bits, not as much savings in bits, but the better choices of resolutions give a better quality of experience in that case. And for other operators, of course, those savings less significant. There are also savings in things like buffering, startup time, but single digits. SSIM values across all, remarkably enough, very close. It's
savings compared to what?
The reference encoding in all cases was recommended HLS guidelines profile.
They're just taking the profile that HLS recommended and versus this
versus the optimized. Now, the next example is try to study and quantify efficiency of the system considering different types of content. So what we did is we basically pulled about 120 hours of programming from major customers of ours, and we split it in assets, and there were about 500 assets, and we did categorization of these assets to 35 or 34 different types. For example, different kinds of sports, different kinds of movies, adventure, comedy, drama, soap opera, and so on. And so it was manual classifications. We literally looked through it, and then we did summary statistics across each category to see what savings we will see across different categories of content. And reference profile was this. This is the same profile in that case. It's a standard Apple HLS profile. And what you could see is that the savings are quite different for different types of content.
Yuri, so forgive me, but the reference profile, this is the Apple technical note.
Yeah.
Nobody uses that in the real world. Right?
Lots of people are using it.
Nobody who's doing large amounts of video is using that. So this seems like a best case illustration. I'm not disputing the numbers at all, but it seems like you're optimistic in terms of the actual savings that you'll see because people are optimizing the profiles based on the content that they have.
You're right. These are savings relative to this profile. For those customers who are using this profile, this will be exact match. For those who use something else, it could still be of value in relative sense because you could see what could be the totals for this and compute yours. But it's actually been used by a number of customers of ours and still being used, remarkably enough. But in any case, what I wanted to say about different categories is this. Of course, for slowly moving content, things like soap operas, movies, dramas, and such, we see savings well over 50%. For sports, it's actually different. So there are sports that are complex and there are sports that are easy. For example, for hockey, we are somewhere in 20s. For swimming is the toughest one, turns out. It's not only lots of waters and splashes, it's also short like segments of runs that athletes are doing and swimmers are doing, and it all in combination makes it very challenging. So we still save about, what is swimming? About 19% in that case, but that's actually most challenging content in this case. But on the other hand, for golf, we're saving 72%. And why we're saving a lot for golf? Well, because there is lots of static imaging in golf. It takes a time for golfer to prepare, to take a right position, right? And these are lots of static pixels that could be compressed much more efficiently. So basically, And you see it's a saving in storage, in number of streams, in bandwidth, and we actually gain in resolution as well across all of them. So pretty good outlook. Conclusions. We started with multi-profiles, and it's certainly a lot of fun. It connects to classical results, bring high potentials for improvements in practice. It plays well to the trend and dynamics in industry to make clients switchable. But of course, there are many other details and more fun to anticipate in the future. Consider a case of H.264 and HEVC, right? There is coming AV1, there is VVC coming, there is also VP9. AV2 is another one that's coming. Of course, with H.264 and HEVCs were three categories of clients. There was one that can decode one, another that can decode the other, and the third one that can switch. So once you start factoring those new codecs, it will be more complicated. Right? Some devices will be able to decode this codec in that circumstances, not in another circumstances. There could also be some licensing constraints. I can easily envision a situation where there will be business logic deciding, do we allow certain streams encoded in this format to go if we have a choice to deliver in another format, and so on. So there will be certainly more work and more fun. And on this note, thank you very much.
Awesome. Thanks very much.